Dear students of English Linguistics, this is Daniel Schreier speaking, and I'm giving the first 3 lectures on English phonetics. Before I start, I'd like to say a few general things. First of all, this is an unprecedented situation for all of us. We've worked very hard to be prepared. We will do whatever we can to make sure that this course continues and that you get your ECTS points and can follow the lecture and do the final test, which is part of the Leistungsvereinbarung. But I should also say that none of us has a handbook for this situation. We've been in contact. We'll do our very best. I've decided to upload this lecture as PowerPoint with voiceover, but I understand that it's not easy to upload on OLAT, and that there have also been some breakdowns throughout the German part of Switzerland. So I hope these PowerPoint slides and also my audio comments reach you in time. Should you have any questions, there's a hotline on the OLAT forum where you can ask your questions. We'll get back to you as soon as we can. Let's get started. This is a slide that you're familiar with. I've removed quite a few slides, particularly movies, movie clips, illustrations, etc. And the lecture as such will also not amount to a full 45 minutes. I'll just run you through what I think are the most important points on each slide. Here you have typical questions in phonetics, difference between different types of phonetics, speech production, what phonemes are used in English, the IPA, which is used to transcribe speech, etc. The essential reading is for the first 2 weeks, which is my lecture. The third lecture will be given by Miriam Schmalz, or Plug, Chapter 1, and Zheng, Dijk, Berryman, Morgan, 2012, which Miriam will incorporate into her lecture 2 weeks time. The learning objectives that you should be able to define different types of phonetics, identify processes of speech production, label speech organs used in articulation, look at places of articulation, and have a basic understanding of the IPA, which is what we do today. Okay, so on slide 4, you have all 3 steps that are involved in phonetics. First of all, speaker-based. From a linguistic to physiological level, from the brain, you have various motor nerves that are connected to the vocal muscles and the vocal tract, which we'll look at. Then you have an acoustic level, which is just sound waves that are produced by alternations of the airstream in the oral and nasal tract and yield the form of sound waves. And then you have the listener-based auditory side of things, where the sound wave hits the eardrum and is then by nervous impulses transmitted to the brain sensory nerves for speech recognition. These are the 3 important aspects of phonetics: articulatory, acoustic, and auditory, and we'll mostly focus on articulatory here in this intro lecture. These here are the definitions of all 3, articulatory, acoustic, and auditory phonetics. In the interest of time, I will not read them out, but they'll give you a good idea of the various approaches and research areas in English phonetics and phonetics generally. First of all, I'd like you to have a little thought experiment. Here you have a bagpipe, and I'd like you to take a minute or so to think about the differences between humans producing meaningful speech sounds and the playing of a bagpipe. I'll think about it for 1 minute, You may want to take some notes. I'll get back to this later on. On this slide, you have a cross-section of the vocal tract. I had a little exercise which was based on a movie clip which I took out. Please ignore that. What you see here, moving up, you see the trachea, and then the glottis, the vocal folds, or also vocal cords as they're labeled here, which I will detail below. This is the area just behind the Adam's apple, which is more protrusive for males than for females typically. Then you have an area labeled as the pharynx, which is a tube between 6 and 8 centimeters long, between the larynx and then the uvula and the start of the oral tract, if you like. You see the tongue, up, front, back root with different parts, which is a very powerful mobile articulator. And then you have lips, teeth, the oral cavity, hard palate, alveolar ridge, the velum, and the uvula. And basically how we produce speech sounds is by moving the tongue around in the oral cavity to produce different types of obstacles, if you allow me to say that, which create air turbulences which are perceived as different speech waves, which are perceived as different meaningful speech sounds, which is described very well in Plage et al.'s chapter. Let's look at this in some more detail. Here's now another cross-section, but this time from the front and not from the side. You have the trachea, and then you have a very narrow opening, which is where the vocal cords or vocal folds, depending how you want to label it, are placed. And then you have the epiglottis, where it widens again, where the pharynx is placed. Very essential in speech production is the vocal folds, and particularly the position of the vocal folds. On this slide, this is basically a laryngoscope, which is inserted via the nose and then films the movements of the vocal folds. You have two slides, left and right. On the left, you see these two cartilages very well that are pressed together and press the vocal folds together. On the right-hand side, they are opened, so there's a wide V-shaped opening, which we refer to as the glottis. What happens here is very important, because the air that streams through the glottis, that is exhaled by the lungs, has some work to do. It either has to push the vocal folds aside, or it can just stream through. And this is a nice illustration of what is known as voicing. On the left, the vocal folds are shut, and the vocal folds vibrate, which we perceive as voicing. On the right-hand side, they're widely apart, they don't vibrate, and there is no voicing. These would be the state of the glottis in voiceless sounds. We'll look at that in more detail later on in the distinction of English consonants. Here there's not much I would like to say, other than that every human voice is speaker specific. Nobody speaks the way that you do. It's a very complex type of endeavor. How we speak, the shape, the weight of the vocal folds, the vocal tract, the weight, the size of the lungs, the structure of the crane, of the vocal tract, nasal tract, etc., all play a role. And also throw in the first term that all of you know, which is hertz. Hertz refers to one movement of the vocal folds per second. So if the vocal folds just vibrate once per second, you have 1 hertz. we have much more than that when we're speaking, and sort of the total number of hertz vibrations of the vocal fold per second goes down as we age. Babies usually cry at a frequency of 500 hertz, which is why they're perceived as having very high voices. This goes down as the vocal folds stabilize and become firmer and less elastic. And adult men finally have sort of an average fundamental frequency of about 125 hertz, which, however, is still a lot when you come to think of it. Here we have the same slide again. So let's look at the role of the articulators. In the vocal tract, the prime articulator is the tongue. Why? Because it's so super mobile and with back, tip and front, you can move all over the place, which contrasts with secondary articulators, which are somewhat mobile, such as the lips. You can protrude them, you can round them, not mobile at all, such as the teeth, or the alveolar ridge, the hard palate, etc., all of which you have labeled here. You also have a velum at the back of the mouth, which is very important as it can be lowered or raised, and thus determines whether or not the airstream enters through your mouth only or through your nose as well. Some languages, such as French, have nasal vowels, nasal qualities of phonemes, nasalization, which you don't have in English that much, with some exceptions. So the velum here we've just sorted out. Then we have the pharynx, that is the area between velum and the vocal folds, and the larynx. All of these are on our diagram. These secondary speech organs are used in many ways. Lips, for instance, can be pressed together. This is what we do when we produce sounds such as p and b. Or they can be brought into contact with the teeth, f and v. As you produce f, you have contact between your teeth and the lips. Or they can be rounded for vowels, u. Teeth the same, alveolar ridge, for instance, s and z or sh are all produced in the alveolar, post-alveolar area, and k and g, for instance, would be produced at the back of the mouth in the velar area. Okay. So one important question, but I'd like to come back to this next week, is how many phonemes does English have? And how does English distinguish its types of phonemes? We'll come back to this next week. Just take this on board, that you have some general introduction to speech production, that you have the articulators, primary and secondary, and you bear in mind that sounds are produced at different places throughout the vocal tract. The International Phonetic Alphabet, this is the second part of this lecture, has been a milestone in the science of phonetics for a number of reasons. First of all, you might like to say, why do we need to transcribe speech sounds? Why is this necessary? Well, for language teachers, for instance, would have to illustrate how sounds are produced in order to teach how these are used. Or you remember your days at school when you just pick up a dictionary and say, how's this word pronounced? And then you have a couple of symbols there that can be used, which are partly familiar, partly not familiar. Singing, for instance, when you're an opera singer and you're singing in a language you're not familiar with, then you need to have some sort of transcription system that is reliable. So the question might say, why not just use the alphabet? Here I'd like you to take 2 or 3 minutes. Take the sequence of letters, O-U-G-H, and try together with your neighbors, or if you don't have neighbors under this very special digital teaching situation, with others via Skype, find several pronunciations for this sequence of letters. Here is an illustration. I take it you already know of tough and bow and cough and dough. Some may stumble, but not you, and hiccup, thoros. And then you say, how is this one pronounced, etc., etc. This is where the dictionary comes in. And this is also where you see that the alphabet as such is not suitable for phonetic transcription, simply because OUGH has very many different pronunciations. This has been noticed for a long time from the domain of language teaching. If there's no matching correspondence between letters in written language and the sounds they correspond with, how do you get this across to learners of any language who need to have such knowledge? On the right, you have a photograph of Paul Passy, who's a language teacher and who was instrumental in setting up a phonetic writing system, founding the International Phonetic Association in Paris in 1886. The original version, set up by Passy, worked just for French, English, and German, and had 30 consonants and 13 vowels, plus a few diacritics, which are additional symbols that give additional information on the length, on additional qualities, etc. This IPA then has been extended and built on. Now covers nearly all languages and ideally all the phonemes of all the world's languages, also including some that you're not familiar with. This is how it looks like. I just took Alice in Wonderland, text that all of you will know. On the right-hand side, you have the original. On the left-hand side, you have the transcript in the IPA. Some of these, as you see, some of these symbols look very familiar, and others are rather conventional and not familiar. The important document here is so-called the IPA, the International Phonetic Alphabet. And I have here some excerpts from the IPA. First of all, this is a list of consonants. The main consonant chart, but there are also non-pulmonic consonants, the vowel chart, list of other symbols, etc. It's quite easy to make sense of because you have a vertical and a horizontal axis. On the horizontal axis, from left to right, you have bilabial, labiodental, etc., all the way to velar, uvular, and so on. And you have different symbols. For instance, bilabial, you have p and b, and they are bilabial, they're produced basically by the lips. Alveolar, you have t and d, so these are produced by the tip of your tongue touching the alveolar ridge just behind your top teeth. N is an alveolar nasal when you have the same, but air is also streams throughout the nose at the same time. And I'd like to draw your attention to the fricatives, where you basically have every cell that is filled. So there are lots and lots of fricatives in English, where you have bilabial fricatives, where there is a continuous airflow, v and v. Then you have labiodental, f and v, that we know, dental fricatives, th and th, and so on and so on and so on. If you have two symbols, the one to the left is voiceless, which means that there is no vibration, or very, very little vibration of the vocal folds. On the right-hand side, you have the voiced one, where there's vibration of the vocal folds. So when you want to know something, how to find, when you want to know more about the pronunciation and also the IPA rendering of English phonemes, you search for the place of articulation, you look for the manner of articulation, and within the cell what the state of the glottis is, whether it's voiceless or voiced. Shaded areas show combinations of features which are judged to be impossible. I'll let you look at this and then let you figure out why it is anatomically impossible to make these particular sounds. There are also white cells. Those are phonemes that could be produced but have not been yet accessed. Okay.